Gentlemen, so we had two bell ringer questions. The first one says, what are the signs of a chemical change? Who can tell me one of the signs of a chemical change?
Change in temperature.
Change in temperature is one. Who can tell me another?
Precipitate.
A precipitate is formed or a solid is formed when two liquids get mixed together. A color change is one. Awesome. What's another one?
Gas production.
A gas is produced. Awesome. Two more.
Energy
substance.
produced.
Energy is produced. What else?
New substance.
A new substance is formed. Awesome. There's one more sign, though, that a chemical change occurred. What's the last sign?
Light occurred.
That one's part of energy, but great. Nice. Light or sound or energy that we're talking about here. What else? One more.
Odor.
Do we say odor yet?
Odor. I don't know.
Potentially. Yes, it sounds right. So let's just go through them again, just so I make sure we said all six. We said that there wasn't a change in odor, a change in our energy is produced, which is light and sound. We have precipitate is formed, or solids formed when two liquids are mixed together. We have temperature change. We had color change, and we had gas release. Thank you, man. Going crazy today. A gas was produced. Awesome. So those six are signs of a chemical change. Then there are also 5 types of reactions. Who can tell me one of the types of reactions?
Single and double replacement.
Single and double replacement. Awesome. I think Daniel said combustion.
And decomposition.
Decomposition. One more.
Synthesis.
Synthesis. Awesome. So now let's go back to our gizmo from, that's the wrong one, from yesterday and Tuesday. Let's actually talk about those definitions. You guys came up with your own, but then they had you do these multiple choice questions, or sorry, not multiple choice, matching questions, where you guys had to come up with which one of these was the correct answer. I'm going to number these 1 through 5, just so we all know. That's not 5, man. 1, 2, 3, 4, 5. There we go. We're gonna number 1 through 5, just so we can say which number and letter we're talking about. So number 1 says one reactant breaks down into 2 or more products. Number 2 says a fuel is combined with oxygen to produce carbon dioxide and water. Number 3 says 2 or more reactants combine to form one product. Number 4 says 2 compounds react to form 2 new compounds. And number 5 says a compound reacts with an element to form a new compound in a different element. So does anybody know a number and a letter that should go together?
B, number 1.
Number 1 in what letter?
B.
You said B, right?
Yeah.
Awesome. Okay, just making sure. B is correct because we have one reactant breaking down to form 2 products. Whenever I hear that word decomposition, in my mind, it always goes to like TV shows and when like murder mysteries, when we have a body decomposing, it's breaking down. So when it decomposes, it breaks down, it breaks apart. And same thing with our reaction. We have a decomposition reaction. We take one reactant, one thing on the left side of our equation, and we're breaking it apart into 2 or more products. Who knows another number and letter that go together?
2, combustion.
2 is combustion. Awesome. A fuel source. So this fuel source is any CH compound. You ever see a carbon and a hydrogen or any number bonded together, and they're being combined with an oxygen. And remember, oxygen is a diatomic, which means if it's by itself, it becomes O2, which is an element. Even though there's 2 of them, it's still an element. And this is going to be our fuel source right here. The CH is our fuel source. And it's going to always make the 2 products, CO2 and H2O. Always tells us it is a combustion reaction here. Any of the other three numbers that we know?
3A,
All right, I got 3A from a few people now. So we take two or more reactants. Remember, reactants are the things we have at the start of our reaction. We're taking two or more of them and we're putting them all together to make one product. So this 3 is going to be A for synthesis. 4 or 5, do we know those?
4D,
4 is D, awesome. 2 compounds react to form 2 new compounds. The thing I always think about here is that the word 2, we're switching 2 things to form that double replacement, which means 5 is going to be which one of those letters, which type of reaction?
C.
C,
C, and that's because we have a compound or one compound, so it's going to be a single replacement. We're only replacing one thing here. Does anybody have any questions on those? All right, so let's go ahead and look at the practice for today. And let's go ahead and try and do number 1. So I want you guys to try it on your own. Take about 1.5 minutes to do it on your own. If you don't know how to identify the reactant yet, maybe identify which ones it's not and try and narrow it down just a little bit. Remembering that we have a synthesis, decomposition, single replacement, double replacement, and combustion as our 5 types of reactions. So try and narrow it down if you can, at least before trying to identify the type of reaction. All right, ladies and gentlemen, so number 1, what type of reaction do we think this one is?
double replacement.
All right, I heard double replacement. Does anybody want to confirm or refute that one? Everybody think it's something different? Or does everybody like double replacement here? All right, I'm taking our silence as everybody likes this one. So let's try and go over why we know this is a double replacement reaction. So remember that double replacement, we start with 2 compounds and we come up with 2 new compounds. Is this a compound right here?
Yes.
Yes, it's got 2 or more elements that are bonded together, making it a compound. What about this one right here? Is this a compound?
Yeah.
Yes, it is. And we know they're compounds and we know there's 2 or more elements because we have more than one capital letter, which is telling us we have 2 compounds here. And did we form 2 different compounds on the product side? Remember, this is telling us we're forming or making new things.
Yeah.
There are 2 different compounds over on the product side, so we know this is a double replacement. We also can see that 2 things are being replaced. So we look here, we have sodium is replacing potassium. At the same time, potassium is replacing sodium to create these 2 new compounds. So sodium replaces potassium. Wow, potassium replaces sodium to create 2 new compounds. How do we feel about this one? Good? Bad? No idea what's going on? All right, how about we try the next one? Try and identify the next one in the next minute or so, and then we'll go over that one. Once you identify the next one, send me it in the chat. All right, ladies and gentlemen, what do we think for number 2?
Double replacement.
Double replacement again is perfect. We got those 2 compounds. And they react, the magnesium and the lithium are switching spots to create 2 new compounds. Let's go through one more together. So again, I want you guys to try and identify that one. Send me your answer when you have it in the chat. All right, ladies and gentlemen, what do we think about number 3? What kind of reaction is that one?
Combustion.
It's going to be that combustion reaction, and that's because we have a fuel source, which is any CH compound. Anything that has CH like that bonded together is going to be called our fuel source, and it's reacting with oxygen, our element, to form these 2 products, CO2 and H2O. Anytime we see that, it is going to be a combustion reaction. Does anybody have any questions in general about this stuff, about our types of reactions? All right, then you guys have 10 more problems to work on for this practice that we'll go over on Monday. If you have questions about this, just stay on. I'm happy to help, or send me messages over the weekend and I'm happy to answer them. Otherwise, have a wonderful weekend and a